Okay, sometimes we're given an equation. So far we've worked with, in our activity, we worked with pictures and seeing the pictures of a graph. The slide that we were just on, we worked with data points or our coordinate sets, our tables, and we were able to determine from that. And now I'm going to go ahead and give you an equation. And there is a way that you can determine just from looking at an equation and not having to actually go through and substitute in for the equation. If an equation can be set up in slope-intercept form, that's that y equals format, then the equation is considered linear. So here we've got both of them that say y equals, but here's the thing that you have to remember. When we worked with the y equals format, we always had our slope with our x, and then plus or minus something in the back. It doesn't matter if we were adding or subtracting, but we were adding or subtracting a constant number. That number did not ever change, okay? So this one would show a linear function if we were to go through and graph it. Okay, and I could go through and actually demonstrate this to you. So let's say I just picked 3 y's, or 3 x's, I mean, just to prove to you what I'm talking about. So let's say for my x's, I wanted to use 0, 2, and 4. So notice how on each of these I increased by 2 every single time. Okay, and if I did 0, 1, 2, that's okay also. Now, just to make it easy, I did choose a pattern in my x's, but the key thing is that I have a pattern in my y's also. So if I were to put a 0 here, 0 plus 5 would give me 5. If I now put a 2 in here, 2 plus 5 is 7. Okay, if I were to then put a 4 in there, 4 plus 5 would give me 9. So you can also see that in this case, I ended up with an increase each time also of 2. Now, it's not always going to work out that way, but it did happen that I had the same pattern on each side. But once again, as long as your x's are constantly changing the same and your y's are a constant change, then that would be considered linear. The second equation that we have here, y equals 1 minus x squared. We have not worked anything with x squared before, okay? So just based on what you've previously learned, this would not show a linear function. It's going to end up being nonlinear. Okay, to prove a point, let's go ahead and pick some x's. So we'll go ahead and do the same x's that I had over on my first one. We're going to do 0, 2, and 4. So if I put a 0 in here, 0 squared is 0. 1 minus 0 would give me 1. Okay, so now we're going to go ahead and put a 2 in here. 2 squared would give me 4. 1 minus 4 would give me negative 3. And now we'll go ahead and put a 4 in there. Okay, 4 squared is 16. 1 minus 16 is negative 15. Okay, so if you notice here, yes, it was a constant change of adding 2, because that's what I chose to do. But then my y's, when I substituted in here, it went down by 4. Here it changed by negative 12. So that was not a constant pattern, okay? So when we're looking at an equation, as long as it's in a y equals with an x and a plus or minus something, then it would be considered linear. As soon as they start changing part of that equation, it will no longer be linear. Okay, as you get older, you also work with absolute values. So as soon as they throw in an absolute value, it's no longer linear. Okay, so here's a real world application where we could see something that's linear versus nonlinear. So it says account A earns simple interest. Account B earns compound interest. So simple interest is you're just going to get so much interest each month or each year, however it's set up. Compound interest is where they're going to take the interest that you've earned the previous month or the previous year, and they continue to add that within. And so you're gaining interest on the interest that you previously earned. Okay. So it says the table shows the balance over 5 years, graph the data, and compare the graphs. So first of all, here's our first scenario. So in blue, I'm going to go ahead and graph this information. So for me, I'm just looking at this. I should be able to determine if I'm going to have a line or a curved line. So looking at this, let's see, all of my T's or my X's, these are my X's, all went up by 1, okay? Those were all increasing by 1 every time. When I look at my Y's, or in this case, they called them my what? account A balance. I guess they did put a Y on my graph over here. So my Ys looks like we increased by 10 every single year. So it didn't matter. I got $10 every single year for putting that money in there, okay? So if we go through and graph this information, we should end up with a straight line. Now, granted, remember I'm working off my smartboard and sometimes it's not perfect, but over to 0 up to 100, over to 1 up to 110, over to 2 up to 120, over to 3 up to 130, over to 4 up to 140, and over to 5 up to 150. Okay, so there's my simple interest, and I could extend that out. You could tell that at year 7, I will have $170, okay? So that's my simple interest. Okay, so let's go ahead and look at my compound interest. So account B, I still started out with $100, but in the second scenario, I'm getting what they call compound interest. So it's changing slightly. So yes, my X's, I'm going to cross these out. My X's are still going up by 1 every single time. That is not changing. My Y's, on the other hand, it looks like year 1, it was going up by 10. Year 2, it went up by 11. Year 3, it went up by what? 12, 10. Okay, so we can see already without even finishing that off that this is no longer going to show us linear. Now, it's going to be hard to see some of these because they're not a huge change, but by the time we graph out year 5, we're going to see a bigger change. Okay, so the first year, at year 0, we had started out with $100, so the same spot. At year 1, 110, that's still in the same spot. Year 2, we were at 121. So slightly above that, it's going to be kind of hard to see that. Year 3, 133.10. So somewhere in there. It's starting to go off of that line, but still pretty close. Year 4, 146.41. So 146 is a little above the middle. So now you can see at year 4, we're starting to see a much bigger gain. Okay, at year 5, it was 161.05. Okay, we don't see much change in years 1 through 3, but then by the time we get out to years 4 and 5, we can see that there is quite a bit of change. I can see that at year 5, it was what, like $11 more. Okay, so that was showing my compound interest. Okay, so graph the data, compare the graphs. So in our graphs, we notice that our simple interest is showing linear, a perfect line, and our compound interest was showing us a nonlinear or a curved line in that scenario. So key things out of this lesson, when looking at a set of data or graphs, or not graphs, non-graphs, but your data points like your X's and your Y's, as long as you have a constant change in both your X's as well as your Y's, then that would be a linear pattern. As soon as there's a change in one of your Y's or your X's, then that is going to be considered nonlinear or not showing you a straight line. When given an equation, a Y equals format is going to show you linear. Remember, you cannot have anything other than multiplication and adding and subtracting involved in that Y equals. So as soon as they do something squared or with absolute value, it is no longer linear. Okay. Good luck with this, and just always remember, you can always revert back to graphing it out if you're a visual person and you need to visually see what that would look like. The unfortunate the downside to that is you're going to have to be able to set up your graphs in order to do that. So good luck with this lesson.